Welcome back to my series, Jam Helping and Physics series. We are still on the topic scalar and vector. We discussed in previous classes how to get the resultant of two vectors when they are parallel, when they are perpendicular, in the same direction, in opposite direction, when there is particular angle between them. So we discussed how to resolve vectors. But in this series, we'll be discussing about how to find the resultant of vectors. In this series, we'll be looking for how to resolve a particular vector into a more useful component. In physics and in engineering, when a vector is inclined like this, it is as good as being useless. It is as good as being useless. When I mean like useless, I mean it's as good as being useless. So for you to make it useful, how do you go about it? It's just like you are given coconut. I believe you all know coconut. When you are given coconut, what do you do to coconut? You can't just start eating it like this. You need to break the bark, then remove the more important part of it, and you need to eat the more important part of it. So the same thing happens to when you have a vector that is at a particular angle. When you have vectors that are at particular angle, you need to resolve them into more useful components. So the useful components are the components that are vertical component and horizontal component. So this is horizontal component, then this is vertical component. So this particular component are the more or most important more useful part of this vector. So you have to resolve this particular vector v, you have to resolve it into vertical component and horizontal component. So there are approaches to solving it. You will be given the angle which it either makes with the vertical, or you will be given the angle which it makes with the horizontal. That is case number 2, when you are given the angle which this vector v makes with the horizontal. So if you are given the angle which it makes with the horizontal, here I have theta, here I have phi. So if you are given the angle which it makes with the vertical component, you resolve it into vertical component, this horizontal component, and vertical component. So the horizontal component is this, the vertical component is this. So if this is angle theta, this is also angle theta. So and this vector is v. The component that is facing the given angle theta is called v sine theta, while the component that the other component will be called v cos theta. Don't forget that. So irrespective of how it's being made, this angle here is equals to this angle here. So when I resolve it, horizontal component, vertical component, the component that is facing the given angle, so in this case is the horizontal component, then the horizontal component in this case will be called v sine theta, and the vertical component will be called v cos theta. What about if I am given the angle which it makes to be horizontal? You resolve it into vertical component and horizontal component, vertical component and horizontal component. So see horizontal component, then look at the vertical component. So the vertical component is moving upward and this is moving in this direction. So this is the given angle. The side that is facing it will be called v sine theta, while the other one will be called v cos theta. Don't forget, the side that is facing the given angle will be called v sine theta, while the other one will be called v cos theta. So in this case, vertical is v sine theta, in this case vertical is v cos theta. So what determines whether it is cos theta or sine theta is which angle is given. Is it horizontal angle or vertical angle? Please don't forget. Please don't forget. So at this point, you need to also understand the concept of the direction of the vector. The direction of the vector, you need to go through it very well. This given vector v is moving upward for you to move from this point A to this point B, you can either go straight or you move to this point C, then from A to C, then from C to B. Don't forget, so you must put your arrow in that direction. Moving from A to B, you can either go straight or you move through the horizontal first to C, then from C you move to the vertical to B. So then the same thing applies for this. If I have P to Q, I can either move to R here, move to R, you see the direction, correct? Then from R to Q, so I still get to the destination. So please don't forget, when you are resolving into components, the direction is also important. The direction is also important. So the next thing we are going to in this topic is how to find the resultant of multi-coplanar forces or multi-coplanar vectors, how to find their resultant. So let's pick an example of multi-coplanar vectors. So I have this. I have a vector acting like this. It makes angle 30 degrees here, and this is 15 Newton. I have another one acting in this direction, which is 10 Newton. I have another one acting in this direction, which is 45 Newton. So which is 45 degree, 30 degree, which is 20 Newton. So in this case I have three vectors, so I will label them vector 1, vector 2, vector 3. So each of the vectors, I want to sum them together and find just a particular representative for all the forces. I mean, to find the resultant of these three vectors. So can we do that? Yes. So we resolve each one into both vertical component and horizontal component. So this 15 Newton, it's making 30 degrees to the vertical. So when I resolve it into horizontal component and vertical component, this is 30 degrees, this is also 30 degrees. So it means this place will be 15 sine 30, and this will be 15 cos 30. So 15 Newton, vector 1, vertical component, horizontal component. So vector 1 is 15 sine, and vertical is 15 cos 30, while the other one is 15 sine 30. Vector 2, I have its only vertical component. So in this case, only vertical component, therefore I have 10 Newton. Horizontal component is 0 because you don't need to resolve it into horizontal component, it's already in vertical component. Vector 3, I have it like this. So when I resolve it into vertical component and horizontal component, I have this and I have this. So looking at this horizontal component, the vertical component is the one facing the angle, so I have it to be equal to 20 sine 30. So the horizontal component will be 20 cos 45. So horizontal component, vertical component is 20 sine 45, while vertical component will be 20 cos 45. So the next thing I need you to understand is the convention which we are supposed to make use of. The convention that any vector that is acting upward will be taken as positive, anyone that is acting downward will be taken as negative. So let's look at this, our resolved vectors. Vertical component of vector 1 is upward, therefore is positive. Vector 2 is moving upward, positive. Vector 3, the resultant in vertical component, is moving downward, so therefore is negative. So let's come to this other side, horizontal component. So for horizontal component, any vector that is moving towards the right hand, we take it as positive, is a convention we want to make use of, and anyone that is moving towards this is taken as negative. So if this is positive and this is negative, let's retake them. So resolving this 15 Newton is moving backward, therefore this is negative. 0 is neither positive nor negative. Then this 10 cos 30, the third vector, is moving in this direction, which is positive. So therefore we now sum them together. Summation of it is force acting along y-axis is equals to addition of the three of them, and this one will give us summation of forces acting along x-axis, which will give us addition of the three of them. So let me have them. Summation of acting along the y-axis is equals to, so I have 15 cos 30 plus 10 Newton, yes, minus 20 cos 45. So the answer x-axis is equals to minus 15 sine 30, there is plus 0 plus 20 cos 45. So when we add them together, what did we get? And lastly, for us to now get the final resultant, which we are looking for, final resultant is equals to square root of summation of forces acting along y-axis, you square it, plus summation of forces acting along the horizontal axis, you square it. You find their total square root. Then remember, it is a vector quantity, so therefore it must have direction. So the angle which it's making with the horizontal is what we are going to get, which is arctan of the vertical component, summation of vectors acting along y-axis, all over summation acting along the horizontal component. So arctan, so some people like to call it tan inverse. Tan inverse is not correct. Tan inverse is cot. Tan inverse, but when you want to call it tan inverse, you call it tan inverse function. So there's difference between tan inverse and tan inverse function. So please don't misquote them. So it's better you use the word arctan. So arctan, summation of f vertical all over summation of x horizontal. So please let me press my calculator and get the answer for you. I have 15 cos 30 plus 10 minus 20 sine 45. Is it? Twenty sine 45. 20 sine 45. So is equals to, so this one is equals to 8.84 Newton. So since it is positive, it's not negative, so I have it acting upward, 8.84 Newton. Did you see it? So then the second one, let's pick the second one, which is negative 15. That's minus 15 minus 15 sine 30 then plus 20 cos 45. So is equals to positive. So is equals to 6.64. If you remember our case 3, when they are acting at 90 degrees, I said you need to copy this one, you copy to the other side, you copy this one, you copy to the other side. If you remember the previous video, so if you have not watched the previous video, please go, then we get the resultant. So from this place you can get the resultant, which is equals to square root of 8.84 square plus 6.64 square. So and then our R, the magnitude of our R is equals to favor. So is equals to 8.84 square plus 6.64 square. Question. Square root of is equals to 11.05 and theta is equals to arctan